Thank you. So I will talk about technology adoption through implementation of a multi-level technology acceptance model. My name is Gilbert Busolo. This presentation is done together with Dr. Lawrence Nderu and Dr. Kennedy Ogada. So the areas of focus, I will deal with the introduction, the objectives of the research, the proposed model, the research design and results, a little bit of discussion and conclusion. There is a lot of need and a lot of focus on technology implementation, and the acceptance process of implementing a technological intervention is very key. So the technology models basically explain or try to demystify the acceptance process when an implementation is being onboarded. So a lot of research has gone into this in terms of a lot of authors, a lot of researchers from even Davis and Kelly. They continue to ponder and even to ask questions and even to do a lot of research on factors or the issues that face users and are very much alive in areas where technology is being onboarded. So this research basically looked at four acceptance models. That is the theory of reasoned action, the technology acceptance model by Davis, the task technology fit model, and the unified theory of acceptance and use of technology. So the objectives of this research are, one is to highlight the important role that technology acceptance model play in the successful adoption of knowledge management systems. The second was to look at the framework of evaluation, discussion, and critique of these four models that I've mentioned earlier. That is the theory of reasoned action, technology acceptance model, the task technology fit model, and the unified theory of acceptance and use of technology. Then the third objective is to propose a multi-level knowledge management system, knowledge management system technology acceptance model for application, and also as a tool for further research. So in this objective, we are looking at some of the physical attributes, the perceptions, preferences, and choices, and then putting them together into a very comprehensive model through that will help data-driven decision making. And then to validate this model through research and even a tool that implements it. So basically, this is the model, the proposed multi-level knowledge management model. So this model, basically, it's multi-level because it looks at three main variables. That is the human variable, the technological variable, and the environmental variable as variables which are key in technology acceptance. From here, if I may, the human variables looks at some of the beliefs, the attitudes, some of the factors that are placed in consideration, the intentions, the behavior, the perceived use, the perceived ease of use, the age of these people that are who are the primary users of these systems, the image portrayed, the gender, the literacy, even in terms of usage and exposure to systems, the security of the user even as they implement this, and their user involvement in system development. So when we look at some of the technological variables, the variables that are basically key and mostly focused on, that is the technology, is the utilization of this technology. How best does it fit even in the environment which it is being used, the security of the data, the security of the system. We look at even some of the things like the functionality of the system. How does it operate? How are the interfaces designed? How is the system designed? That is the user experience aspects. The frequency of use. How frequent is this system being used? What are the thoughts even on the quality of the output of the system in very many ways? And at the end of the day, what kind of support is available even as this system is being used and even implemented. One of the other aspects that the model proposes is the environmental model, variables, the factors that exist even in the around this system. When you look at some of the things like policies, positive policies are very key in implementation of system. The strategy, does the system fit into the strategy, that 1 year, 2 year, 5 year strategy of that organization? The top management support that comes in through leadership and management, so that we have support even from the top levels, even as our system is being onboarded. There's some of the rewards, incentives, ease of use, things like that, that comes even in terms of when you're looking at how this system will benefit the user. We have the mandatory and the voluntary system use. We have some of the laws that are there. Do they prohibit? Do they support? We have training and induction, the training, capacity building, tooling, retooling, rekitting, things like that, and also the security that is there even in that environment. And all this is connected through feedback channels and makes up the multi-level knowledge management acceptance model. So this research was descriptive in nature, where there was a systematic investigation and understanding of the existing conditions, characteristics, and behaviors related to knowledge management acceptance across multiple organizational levels. So the descriptive design allowed the comprehensive exploration of knowledge management acceptance, capturing every detail as we went by. On data collection, we did a targeted survey using semi-structured questionnaires, and this was administered to ICT personnel in government institutions, which basically provide public-facing services to its citizens through automation, and even private organizations who provide services even as they undertake their mandates, and also deal with development, production, and support of this system. So the questionnaire included both closed and open-ended questions, and which provided quantitative and qualitative data, allowing for such a rich exploration of the factors influencing acceptance of knowledge management. So 118 questionnaires were sent out. We managed to get a response of 98. 20 did not respond, having a response rate of 83.1%. Looking at the demographic information of the respondents, we are looking at the age, we looked at the gender, experience, and even education level. And from here, you can clearly say that we had an average of 31 to 35 years of age in terms of the respondents. Of male gender, male were more than female. And then also, majority of these respondents at least had a bachelor's degree. So even as we look at some of these results that came out of these three main variables being analyzed and looked at, for the human variables, we see that it came out very, very strong. From a mean, a low of around 3.5 to around 4.5. We can see that factors like computer literacy, exposure to systems, experience came out very strongly. You can see aspects like the attitude and the beliefs also was there. We can see the perceived ease of use. When users feel that this system will help me do my work, will help me meet the goals, will sort a certain problem, will just help me deliver better, it is a strong factor that came out. Also, something else, even if I may mention, is user involvement in system development also came out very strongly, where users accept more. The acceptance of a technology is higher when the users are involved right from the start. Other issues like the behavior, other issues like the image and gender scored a little bit lower. cementing the fact that these can cut across both genders. We looked at the technological variables, the variables that affect the technology, that look at the product itself, even if it's a system or something like that, we see also this one was very, very strong. We are looking at issues to do that came out very strongly, issues to do like the technology fit, how best does this technology fit in that scenario, how best does it answer basically the user requirements and the functional requirements. We are looking at things like the system interfaces, making the usability, the user experience of the system quite high. We are looking at the perceived output quality. When somebody sees that this thing is working well, will work well, will help me deliver my mandate, it comes out very strongly among others. On the environmental variables, that is, these are the conditions, the things that exist even around us. We looked at things around 4.52, having a mean of 4.52. That is the organizational policies. That is, the laws governing an organization are very key to support implementation of a system. You're looking at leadership and management. There needs to be top support, top management support, and even being led from the front by actions, coming out very strong. Even in this thing, we are looking at aspects to do with training and induction. When training is done comprehensively well, induction into the system, into the process, into the new procedures is done quite well, it scores very, very highly. And even some of the other aspects, even as the laws that should not prohibit the use of the system, or the system conforming to the laws that are available even in that operating environment. So some of the other tests that were done even on this were for outliers, for normality, linearity, multicollinearity, homoscedasticity, and even correlation and regression analysis were performed. Even on correlation, that is looking at the association between the human, the technological, and environmental variables, which are the independent variables vis-a-vis the dependent variable. They scored very highly. Humans scored very, very well. It works well. It is the person. The person is the factors of human are very key. When the person is okay, accepts the system, the attitudes are correct, the beliefs, the behaviors, the perceived use, the perceived ease of use is positive, the technology acceptance process is easier. When also, again, secondly, we look at the technology itself, it fits into the user requirements, it fits into the functional requirements, it fits into the use or the need that exists even at that particular time. The process, again, of technology acceptance is end up. And then again, now we look at some of the other factors that exist in the environment around this technological implementation of this technological system, also scored at 0.78. We did also regression analysis, where we looked at these three factors variably collectively account for around 96.2% of the variability in technological acceptance, meaning that there are still some other factors outside the ones which are considered for this research that exist and are key for further research. And this brings us up, basically tells us or continues to encourage us that further research even on this models are key. When we look at some of the things like analysis of variance, that is the ANOVA model, we look at still it at around 96%, 96.3% in terms of variability in technological acceptance. Basically, and this is very consistent with the R-square value. And this basically confirms the previous one. So even in terms of discussions, which we looked at, even as I did the tables, we could see that for the human-related variables, in terms of weights, computer literacy scores very highly. Perceived ease of use comes, the attitude towards even this implementation, towards the proposed system, and things like that, towards the process, comes and scores very highly. The user security, how secure am I even as I use this system, perceived use, the intentions, and then also the user involvement in system development right from the start. So for key factors as user buy-in. So for the technology-related variables, we see issues like system support. Even if I bring on board this system, even when I embrace this system, how is the support even after the development phase, when the production phase is over, when it goes live? What kind of support will I get even through using this system? Scored very highly. The perceived output quality, when somebody believes that as I use this system, the quality of my work will be higher, the level of acceptance becomes higher. The interfaces enable us to move from maybe one menu to another, one form to another, one field to another, and that comes in very, very strongly. We look at the security of the data. Even as I continue to use this system and I continue to generate data, how secure is this data, and how does this technology fit into my user requirements? And then also as aspects of functionality, the design of the system itself, and the utilization of this technology, not mentioning system security and frequency of use. When you look at some of the factors that exist even in the environment, that is the environmental related variables, you look at factors like training and induction. Once this system has been implemented, will I get the prerequisite training? Will I get enough training? Will I be inducted well even into this system so that I know what is expected, I know how the system works, to a fair point where I can use it well to meet my objectives? The policies of the system, how do they support positively the use and the implementation and the acceptance of a system? Again, as I mentioned, one of the very key things is support from the leadership and management came in very strongly. Again, the organizational strategies. Does this implementation fit into the plans, into the strategies of this organization? The laws that exist even in the land, the environmental security, how secure am I? How is the security of this environment that where this implementation is being made? What other measures have been done to make sure that this is very secure? So the anticipated rewards and incentives, and then the issues to do with systems which are mandatory in nature and also voluntary in nature. So from the regression analysis, we can see even the low level and the high level, upper level, the lower limit and the upper limit. We find that human variables come in very strongly, and then after that followed by the technological, and then the environmental variables. And out of this, the findings are very key and provide sufficient evidence to reject the null hypothesis that the multi-level knowledge management acceptance model is insignificant to successful, that is the null, to successful technological intervention implementation. That is the null hypothesis. So in conclusion, in this time and age, many applications, many instances where service delivery, where manufacturing, where education, where every sphere of our lives is being automated for quality of service, for ease of use, for penetration in terms of availability of service, for high availability and things like that. The proposed multi-level technology acceptance model validates the use of models even in proper positive use of guiding the process of implementing a technology. So at the end of the day, this study concludes that technological acceptance for service delivery, even in the Kenyan public sector, is significantly predicted by the three main variables, that is the human, technological, and environmental. So in order of strength, the human variables come in first, the person. The key user, the main user, comes in first. Then the factors around the environment, and then the technology is third. So thank you very much for taking your time to listen.